Hi everyone, and welcome to the European Chatbot and Conversational AI Summit. I hope that everyone had a really amazing day so far, and I'm sure that there is still lots to learn and network about. I'm very excited to see you here in my session, which is called A Quick Introduction to Rasa Chatbots from the Command Line. My name is Justina Petraitytė, and I work at Rasa as a head of developer relations. And I'm very excited about this session today because we will be spending an hour learning the fundamentals of Rasa open source and how you can build AI assistants simply using the command line and Rasa library. And this will be a very gentle introduction to Rasa open source and building conversational AI assistants with Rasa. But I hope that after this session, you will include Rasa open source into your toolbox and maybe even leave the session with a working assistant on your computer. So this session is a workshop, so you are very encouraged to use your laptops as well and follow along. But at the same time, if you prefer listening and playing around with Rasa open source after this session, that is also completely fine. So here is a quick agenda for what we will cover in this 1 hour that we have for our session today. So first of all, we will start with a quick intro to installation and setup. I will show you how you can set up your working environment and how you can install Rasa open source and basically have a working directory working for this specific workshop, or you can use it later on for any Rasa assistant that you would like to build. After that, I would like to give you a very quick intro to key concepts about Rasa, how does it work, what is Rasa in the first place, so that we are all on the same page. And after that, we will dive into the practical part of the workshop. I will show you how you can create a very simple project to familiarize yourself with Rasa and see how Rasa works in action. And then later on, we will actually build that assistant up and we will add slots, we will add custom actions, and it will help you understand the inner workings of Rasa even better. And then I will finish the session with giving you some tips and knowledge about how you can go beyond building simple bots and what kind of things and what kind of techniques you can use to get there. And finally, we will wrap up the session with lots of additional resources that I would like to share with you that will hopefully help you to continue your journey in using Rasa open source and building conversational AI assistants with it. So to kick things off, I would like to start with showing you how you can set up your working environment. There are a few steps, but they are quite simple steps, and I will walk you through all of them so that you are all either have working environment ready for this workshop or you know how to do that after the session. So the first step that we have in our installation guide is making sure that we have the correct Python version installed on our machine. Rasa open source supports two Python versions as of now, Python 3.7 and Python 3.8. For the simplicity of this workshop, I would like to ask everyone to have Python 3.8 installed on your machine. To double check that, you can run a simple command python 3 -- version, which I will do as well. I will use VS Code as an IDE for this workshop. You are also very welcome to use simply your terminal, your command line, or you can use any other IDE, PyCharm, for example, but VS Code is my choice of the IDE for today. So first of all, I would like to check if I have the correct version of Python installed on my machine, and I will do that by typing the command python 3 -- version. And as you can see, I have Python 3.8.10 installed on my machine. So I think I'm good to go and run the next steps. If you don't have Python 3.8 installed on your machine, simply look up Python installation guide for installing Rasa 3.8 and you should be good to go. Next, what we need is a working directory for our project. So we will create a directory called Rasa Workshop specifically for this session, and we will navigate to that working directory so that we keep all of the workshop files in one place. So back to my IDE, and I will create a directory called Rasa Workshop. So I will run the function mkdir, which stands for make directory, and provide the name for the directory, which will be Rasa workshop. And now that my directory is created, I will navigate to this directory and I will do cd, which stands for change directory, and provide the name, which is Rasa-workshop. Okay, so now you can see I am inside of the Rasa Workshop directory, and also I can see Rasa Workshop as one of the folders that are available now. I created this on my desktop in general, and it's empty right now, so that's why I can't really see anything inside of this directory just yet. Okay, so the next thing that is very important when working with Rasa open source, and it's in general a really good practice when building any kind of applications with Python, is using virtual environments. I would like to emphasize why. So when you use virtual environments for your projects, you are able to isolate your project files and in general working environment from your system and your system environment. This is very beneficial because when you are installing some dependencies, additional libraries, you don't run the risk of some dependencies conflicting your system dependencies, or even more importantly, you don't run the risk of overriding some system dependencies by installing some additional Python libraries, for example. And it just makes your development environment really nice and tidy, and it's dedicated to that specific project. So again, it's a very good practice to follow for any kind of applications and work that you do with Python, but it's something that we highly encourage to follow as well when building AI assistants with Rasa. So we will create a virtual environment with a simple command python 3-m vn, and then providing the directory for where the virtual environment will be created. And then we will activate that virtual environment with running the command source and pointing to the activate script inside of the virtual environment. So let's do that. So creating the virtual environment, python 3-m vn, and now we can provide where that virtual environment will be located. So that will be located inside of the vn directory for me. So I press enter, and now you can see that inside of this Rasa Workshop folder we have vn directory as well. So since we have the virtual environment created, we can activate it by typing source vn bin activate, and you can actually see all that. So I'm inside of the Rasa Workshop directory and vn directory, and if I go to bin, I can see that there is activate script, and this is exactly what we have to point to activate the virtual environment. So this is done very quickly, and you can see that we are inside of the virtual environment because you can see that now our working directory has the vn inside of the parentheses at the very beginning of our shell. So we are good. And the last step that we have to do is we have to install Rasa open source. To install Rasa open source, there are two things that we have to do. First thing that we have to do is we have to update our pip command, and we have to install Rasa open source. The reason why we have to upgrade the version of pip, and pip, by the way, is a package manager for Python, which makes it easier to install and upgrade packages, is because for some dependencies there are actually some conflicts when installing Rasa open source. So to avoid that, we have to simply upgrade our pip. If you're running this on simply your local machine, you will probably have to exclude the user command here. So I will just show you how that looks like. So let's do that. So first of all, let's do pip3. And then we have install u. U means that we are upgrading. And what we want is we want to upgrade our pip installation. So we will do that. And then another command that we will run is pip3 install Rasa, which will install Rasa open source. So I will type double N sign, and this will simply execute another command. Now we can type in pip install Rasa. This will install the latest version of Rasa, which is correct and necessary for our session today. So once again, what will happen here, we will upgrade our pip installation with pip3 install u pip, and we will install Rasa open source with pip3 install Rasa. So if I press enter, if everything is okay, we should do both of these commands here. This process overall will take from a few seconds to maybe a minute or so. If there are any issues along the way, upgrading pip or installing Rasa, you will obviously see some error messages in your terminal. If you are following this workshop right now and you encounter any issues, please raise them as we go. So this will take just a few more seconds and it should be done very, very quickly. While it's running, I will just go back to my slides so that those who maybe missed the commands can have a look at them once again. All right, so it seems like the process has finished for me. Just to make sure that everything worked well, I would like to double check that I have the latest Rasa version installed. And this can be done by running the command rasa -- version. So I will do that, rasa -- version, and this will print out, if everything was installed correctly, the current version of Rasa open source and some additional system details for me. So as you can see, I have Rasa version, which is Rasa 3.0.8, which is correct. This is the latest Rasa open source version right now. And then we also have some details about additional Rasa tools that are available, like Rasa SDK, Rasa X, and so on. So we don't really need these details for now, and it's not really relevant for this specific workshop. Yeah, so we have Rasa open source installed on our machine, and we are good to go. We are good to get started with the workshop overall. So before we dive even deeper and start our work on the Rasa Assistant, I would really like to give you a very quick introduction into Rasa open source, what it is about, and what kind of things you can do with it, and in general how things look under the hood. So this will be a very, very brief and quick introduction to Rasa open source. So overall, Rasa open source is a machine learning open source framework for building text and voice-based conversational AI assistants. So the diagram here is a very, very simplified way to showcase the components of Rasa open source and what kind of process user messages go through until an assistant responds back to the user. So let's say we have a user, they want to change their address, and the first component that this message usually goes through is some kind of connector module. So this can be either some kind of live chat, messenger, specific app, or even just a command line like we will be using it for our session today. And then the next step that this message will go through is a natural language understanding component, NLU. And this is necessary for an assistant to understand what is the user message about. So an assistant has to understand what is the intention of the input. So an assistant will do intent classification under the hood at this step. And also, is there any additional information that an assistant should extract from user messages? So for example, extract some details like numbers, dates, or anything similar. This is why at this stage, at a natural language understanding stage, an assistant might extract entities as well. And then having these details like intent of the user input as well as extracted entities, an assistant can go ahead and decide how to respond to the user's input, also including history of the conversation and context of the conversation. And this is what machine learning dialogue management is responsible for. It's a machine learning based mechanism that an assistant uses to predict what should be the best next action, knowing what the user's current message is about, and also what the conversation was about until this very moment. In addition to that, your assistant might have some backend integrations to APIs, databases, and other platforms and extract some additional data from those sources and use those details as well to make decisions on how to respond. But ultimately, when an assistant makes a prediction on what should be the next best action to respond to users' input, we have a response selection component which either creates a text message that is sent to the user, or it might be an action that an assistant will have to execute at this specific state of the conversation, or something else that would have to happen as an assistant's response. And when the correct response is created, an assistant sends that response back to the connector module. So this is how the user will get the message back and understand what an assistant is saying. So this is a very simplified way to look at how Rasa open source works and how Rasa open source makes decisions. All right, so back to my working environment. And the first thing that I would like to do, I just want to clear all of this view so that you can see better what is happening and what am I doing. And there is a really good command called clear that will simply clear the previously executed outputs of the commands. All right, so now since we have Rasa open source installed in our working environment, I would like to actually create a simple project that we can use as a basis for this workshop and then build it up as we go. Rasa open source comes with a command called Rasa Init. And this command will create a simple Rasa assistant that we can use to better understand how Rasa works on a technical level, but also we can use it as a basis for this project or any other project that you would like to build. So I will press enter, and now Rasa will ask a few additional questions. So first of all, it will ask to provide the path where the project will be created. So we could use the default current directory, but just to make everything a little bit tidier and clearer, I will create a directory called bot where I would like my assistant to store the files for this assistant. And since it doesn't exist, I will ask my assistant to create this path. Now, if I check, I can see that I have the bot directory and also my virtual environment. Now Rasa asks if I would like to train my initial model. And so what is happening here? So as I said, Rasa Init creates a simple Rasa assistant, which is very basic, very simple. And this assistant is built to cheer people up if they feel sad. So if the user is sad, an assistant will try to cheer the user up by showing a picture of a cute tiger cub. And with Rasa Init function, Rasa by default will create some training data for this assistant, all the necessary files, models and things like that, and it will actually train those models. So I will ask Rasa to actually train the model because I will want to show you how this assistant works in practice. And now what is happening is Rasa configuring the policies and the pipeline and training all of these components. And one thing that I want to point out here, as Rasa is training the model, you can actually see what kind of components Rasa is using. So you can see that Rasa will use regex featureizer and some other featureizers for the NLU model, also the diet classifier for classifying the intents and entities and other components, and the same for dialogue management. You can see that an assistant will be using memorization policy, it will use rule policy and TED policy and so on. So it's just a really nice way to get a little bit more information on what is happening under the hood and what kind of components will be used for your assistant. So now the model was trained and saved locally on disk, and we can actually test the assistant in practice. I would like to do that so that you can get a better understanding of what Moodbot is about. So I will type yes. I would like to talk to my assistant in the command line, and now what is happening, Rasa is starting a server for my assistant. It's a local server, and loading the model so that we can actually test it. So that should happen in a few seconds. Okay, so the bot loaded, and now we can type a message and talk to our assistant. So I will start the conversation with saying hello. And an assistant asks, how are you? So I will say, I am sad. And now an assistant says, hey, here's something to cheer you up. I have an image for you, and it's a link to the image, and this is basically the output of that image. You can copy that link and paste it in your browser as well, and you will see a picture of a cute tiger cub. And then assistant asks if that helped me, and I will say yes. If you would like to play around a little bit more with the Moodbot and test it more, you can have another conversation by first of all typing restart /restart. And this will simply restart the conversation, and now I can talk to assistant once again. So for example, I can say hi, and assistant says hi, hey, how are you? And I might say I am great, and an assistant says great, carry on. So this is how Moodbot works. I will stop the conversation by typing in /stop, and the server is now shut down, and an assistant is inactive. So I would like to use the Moodbot to first of all explain you the file system of the Rasa assistant, and then later on we will build up this assistant a little bit more so that you can understand what is really happening. All right, so there are a few files and concepts that I would like you to understand at first before we actually customize the Moodbot. So I will open this folder, bot folder, and this is where all the Rasa assistant files are. As you can see, we have quite a few files here. I would like to talk about the most important ones and the ones that we will be using in this session. So first of all, very important directory is called data. Rasa open source is a machine learning based framework, and for any kind of machine learning model, you will need training data to train the models. And in Rasa, you will need two types of data. One is a data file for your NLU model, so NLU.yaml file that is really important here, and then you will need some training data for your dialogue management system. And for dialogue management system, Rasa has two options. You can either write conversation stories or you can write rules. So let me show you how all of that looks like, so I think it will make it much easier to understand. So first of all, let's talk about the NLU training data. I will open up this file here, make this a little bit smaller. All right, so inside of the NLU.yaml file, you will see quite a few training examples. All of these examples are written for the moodbot. NLU data consists of two main things. So you will need to provide an intent and an intent label. So for example, you can have an intent label greet, you can have intent label goodbye, affirm, or anything else. So basically it represents what the user's input might be about. It's a class for that specific input. And then you will have to provide a few examples of how the user might say that specific thing. So for example, you might provide a few examples how the user might say hello to the assistant, how the user might say goodbye to the assistant, and so on. Now, obviously, a very important thing to mention is that since NLU models are machine learning based models, it means that at some point your assistant should learn to generalize on unseen user inputs, which means that you don't have to write all the possible ways of how the user might say hello to the assistant or how the user might say goodbye to the assistant. It's really what matters is to provide at least a few high quality examples, and your assistant should start learning quite a lot from those examples. And another detail that you might want your assistant to be able to extract are entities. And right now our moodbot doesn't have any entities in the training data, but I will show you how that works, and we will actually create some entities by hand, so you will understand how entity extraction works as well. But simply speaking, for NLU model, you need some intent labels and some examples. For every new intent that you add, obviously you will need at least a few training examples. There is no specific fixed number for how many examples you have to provide, but I would say on average for each intent, at least 5 to 10 is a good starting point. So that's about NLU data. For dialogue management model, you need some stories or /and rules. I will start with stories. Stories, inside of the stories.yaml file, there are 3 of them, and stories are basically representations of sample conversations that your assistant could learn from. In general, stories represent actual conversations that might happen between the user and an assistant. They are just simply written in a format that your assistant can understand and use to train the models. So let's take this very simple story as an example. This story is called Happy Path, and the Happy Path basically means that a conversation goes perfectly. Your assistant doesn't need to ask any additional questions. It's a very simple conversation, and it's very easy for an assistant to handle the request, and the user gets what it wants. So it's a very simple and basically the perfect conversation that you would like your assistant to handle. So what is happening here? We have 4 steps. We have the first step, which is an intent greet. Basically, the user says hello to the assistant, and assistant responds with an action. Action is basically assistant's response. Action can be either text message or voice message that an assistant would send back to the user. It can also be an actual action, for example, triggering an API or I don't know, setting a reminder to do something for the user, and so on. But in this case, we have utter greet. Utter in Rasa open source usually means that this action will be simple text message that an assistant will send back to the user. And by the name of this action, utter greet, we also get the indication that probably assistant simply responds with hello back to the user. And then the next intent from the user is mood great. And we can double check, but if I go back to my NLU data, intent mood great represents user saying that they feel great, that they feel amazing, and so on, which means that user doesn't even feel sad. So assistant don't even need to cheer the user up. And an assistant will respond with utter happy, which by the name itself, I'm guessing that it's simply saying that it's great, so carry on with your day. So this is one conversation example, but obviously to train your assistant and be a little bit more versatile in terms of what kind of conversations your assistant can handle, you should provide at least a few examples of how the conversation could go. Again, if you use machine learning policies like TED policy, at some point your assistant will learn to handle a little bit more complicated conversations. It will learn to handle conversations with more conversational turns, and it will start to generalize on unseen user inputs. So here we have 3 other examples of how a conversation might go. So here we can see that user says that they are unhappy, so assistant tries to cheer the user up, and user seems to feel happy at the end of the conversation. And a second example simply says it's a very similar conversation, but looks like at the end of the conversation, user still feels unhappy because they said that they are not happy, and then assistant simply ended the conversation. So these are stories. Now, what about rules? Rules are quite unique feature in Rasa because, as I have mentioned, we have rule policy in Rasa, and rule policy kind of is responsible for all the rules related things. And with rules, you can impose either some business logic on your assistant or simply sort of restrict your assistant so that if in a certain situation you know that your assistant should always respond with a specific thing, you can write a rule for it. So for example, here for the mood bot, we have 2 examples. This rule means that if the user said goodbye, assistant should always respond with goodbye, like there is nothing else to say. So that's why we create a rule with 2 simple steps. If the intent from the user is goodbye, then assistant has to respond with an action utter goodbye. And then, for example, if the user asks an assistant, are you a bot? So then assistant should respond that, in fact, it is a bot, it's not a human. And also it's a general practice that we encourage people to follow when building assistants. Make sure that assistant can communicate to the user that it's not a human, that it's assistant, so that users can manage their expectations as well. So this is how stories and rules look like. Again, as always, and just like any other machine learning problem that you have to be very mindful about your data. Quality of data is crucial. You won't be able to build a good assistant if your NLU data is messy. For example, if you have exactly the same examples for mood great and then the same examples for mood unhappy, obviously your model will not be good. And the same applies to stories. If you have a lot of conflicting stories and so on, your assistant will simply be all over the place. So when you do write training data for your assistant, and at the very beginning of your development phases, you will probably have to write some training data from scratch and maybe even by hand. Be really mindful and try to really cherry pick good training examples, and then later on, we will talk about that, as you expand on building your assistant up and involve real users to test your assistant, you will have more rich and real world data to improve your assistant as you go. And then there are 2 additional files that I wanted to show you for now. One of them is domain file, domain.yaml file. It's a very important file. Domain file basically represents the universe of your assistant. This is where assistant kind of keeps all the knowledge that it needs to be aware of. So what kind of intents the user might send to the user, what kind of responses to send back to the user, and this is where you can actually write those responses. So for example, you can see that we have utter greet response, and we actually have text saying, hey, how are you, and so on. So you can define these things here. And then if your assistant has some kind of custom actions, you will have to list them here. If your assistant extracts entities or saves some information in the memory as slots, we will also have to define everything inside of the domain file. So your assistant constantly references this domain file when checking what kind of thing it can do or what kind of thing it should be able to understand. And last but not least, config.yaml file is very important. For now, since Moodbot is a very simple assistant that is designed to learn about Rasa open source and sort of kickstart your project, everything here is commented out. But basically, inside of the config.yaml file, you can define your own custom pipelines for the NLU models, for the dialog manager model. So this is where all the sort of machine learning stuff happens. So you can define the pipelines. As you can see, you can also configure the parameters for the models. By default, Moodbot comes with a default pre-built pipeline. But if you want to, and this is the representation of that pipeline that is being used, but you can customize everything, and you can actually uncomment this and make changes to the pipeline and what kind of policy components are being used as well. So in general, this file will probably become way more important for you later on in the development stages, but it's a really good and important file to keep in mind when building your assistants. So these are the most important things about understanding the key components of Rasa Assistant. There are more things, but we'll actually learn about them as we go. And now what I would like to do is I actually would like to enhance this assistant a little bit so you can see a little bit more how things work in practice. Okay, so here is a little thing that I would like to do for this assistant that I think will give you a little bit of a hands-on experience when using Rasa and get you more familiar with even more things about Rasa open source. So let me show you what I would like to achieve by giving you a quick example. I will load the Moodbot once again and have a quick conversation with it once again and show you what kind of situation I would like to improve. So to load my assistant once again, now that it's down, I can use a command called Rasa shell. And this will load the latest trained Rasa model. I will clear the working environment for now. And one thing that we have to make sure as well that we are inside of our bots directory. So I will do cd bot. So now I'm inside my bot directory, and if I do ls, I will see all of the bot files that we discussed already, like domain, data, and so on. So now that I'm here, I can run the command Rasa shell, and this will load the latest trained model that we have inside of our models directory. So let's do that. And I will simply talk to my assistant. It will not need to retrain the model, but I would like to have a quick conversation with it so I can show you what I would like to do now. And in general, Rasa shell is a great way to test your assistant as you work with it. So it's always useful. Okay, so assistant is loaded. So there is a little problem with Moodbot. So when the user are feeling unhappy, so I will just have a quick conversation. Hello, how are you? I will say I am sad. Assistant tries to cheer me up. And then if I did become happier because of seeing that cute tiger cub picture, I can say, yes, it did help me. And then assistant says, great, carry on. Now, if I still feel unhappy, let's see what happens then. So I will say, hello. So I say, how are you? I say, I am sad. So assistant tries to cheer me up. And what if I say that it didn't help me? What if I say no? Assistant says bye. And I think it's just a little bit rude. Because if I'm already sad, it's not very nice to just hear bye from someone. I think it's a little bit cold and not so friendly. So what I would like to do is I would like Assistant to be a little bit friendlier and just try again. So if at this stage of the conversation, user says that they still feel unhappy, I would like my assistant to try a little bit harder. And I would like my assistant to say that, for example, assistant could tell a joke or send me a funny meme, and maybe user could choose if the user would like to see any of those, and try to have a little bit friendlier conversation once this kind of situation occurs. So this is what we will be working on. We'll have to make a few changes to our assistant, so let's get going. I will stop the conversation for now. The first thing that we have to think about is, do we need to add any additional NLU training data? So in this situation, what I will want my assistant to do, instead of saying bye, I will want my assistant to say, I can tell you a joke or send you a funny meme. Which one would you like to see? And what my assistant will have, what the user will have to do is they will have to choose whether or not they want to see a joke or a meme. So that will be a little bit new kind of information that my assistant will have to handle. And for that reason, I will have to create a new intent for my assistant. So I will go to the nlu.yaml file and I will create a new intent. I can do that at the end of the file. And I will call that intent inform. So this is basically will be about the user informing about their choice. What, do they want to see a joke or do they want to get a meme? And now we need to provide a few examples. So examples will be, and we have a freedom to type what kind of examples we would like our assistant to be able to handle. So when my assistant will say, which one would you like to get, a joke or a meme? So the user might say, I want to see a joke or a meme. They might say a completely long input. I would like to get a meme. Please show me a meme. Tell me a joke. And then could be something like joke, please, or meme, please, and so on. Okay, so we have a few examples. I think maybe we can try with this, and hopefully that will be enough for our assistant to learn. So we have a new intent. It's great. Now another thing that I would like you to think about. Okay, so a user will be able to choose whether or not they want a joke or a meme. So for assistant then to be able to act on it and either find a funny meme or tell a joke, the choice of the user is important. So we have important detail in user's input that an assistant should be able to understand. So with simply providing intents, our assistant will understand the intention, that this is basically informing the assistant about the choice of the user. But to actually understand what kind of choice the user made, we will have to extract entities so that assistant can use that entity later on to act on user's request. So now I would like to show you how you can enable your assistant to extract entities. To extract entities, you have to do two things. First of all, label the entity inside of the example, inside of your nlu.yaml file. And to do that, you only have to add the brackets around the target word that should be extracted as an entity. And then next to it, inside of the parentheses, you can provide the label for that entity. Just like we have labels for intents, we will have to have labels for entities. So what kind of entity that is? I will call this entity user choice. So this will be the label for this entity. For example, here, meme is, if you guessed that it should be an entity, you are completely right. So this will also be user choice. Again, what we write in the parentheses is the type of the entity. So it's a label. Because you can have other entities, like for example, numbers. You can have entities like dates and things like that. And this will simply extract what choice the user made. So I will just, to make this quicker, I will copy meme and I will replace it here. I will place it here as well so that we have the labels, and we also have it here. And we also have a few additional joke examples. So a joke should be labeled as well, and here. And now I think we have all of the entities extracted and labeled. So that should help our assistant to make a little bit better choices. So very important, let's save this file. And now what we have to do is we have to go to our domain file. Remember, I said that domain file is a universe of your assistant. So this is where we have to provide the information about what kind of intents our assistant is able to understand, what entities our assistant is able to extract, and so on. So inside of our intents list in our domain file, we don't have the new intent that we just created. So I will add that. I will simply add another one at the end, which will be inform. And we don't have entities specified here. So it's a new section that we will add to the domain file, which will be called entities. And now we can provide the entity, which we called user choice. Just to double check that I called it exactly the same way as we did here. So it's user choice and inform. So back to the domain file. Okay, great. This is really good, and this is really great progress. So now we are able to enable our assistant to understand what user is saying. And we can actually test it. So now if I save this file and retrain the model, I can retrain the model by typing Rasa train inside of the shell. And this will, for now, should only retrain the NLU model because we provided some new NLU training data. So in a few seconds, the NLU model will be retrained, and we can actually test if our assistant is able to understand the inform input. So that will be another really good learning for you, because you can learn how to retrain the models and how to test them. So just like previous time, we will have to just wait a few seconds, but that should not be very long. Okay, so the new model was trained, it was saved, and now I would like to test this model, and I will only test the Rasa NLU model. So I can do that by typing Rasa shell NLU. And this will load only NLU model, and now we can test it on different user inputs and see how Rasa handles those inputs. So this is loading the NLU model only. Okay, so then NLU model is loaded, and now we can simply type user messages and test the NLU model on it. So I will start with a very simple example, hello, and now we can see what kind of information Rasa extract from that input. You can see that the text is hello, the intent that was classified for this is greet, you have the confidence, how confident the model was with this prediction, And then you also have intent rankings for other potential intents that we have in our training data. So I would like to test that. Tell me a joke, for example. So I will type a joke and let's see what happens. Okay, perfect. So you can see that the message a joke is classified as info. It's exactly what we wanted. And also we can see that entity joke is being extracted. You can see the label for the entity, user choice, where in the user's message that entity is, how confident the model was, and what extractor was used to extract this detail. This is great. So you can play around and test your NLU model on more things, but this is just a really nice way to see if your assistant is able to understand things you would like your assistant to understand. So, and this is a really good debugging tip. If you see that your assistant is not performing very well, you might want to check how your NLU model is performing and look for issues there first and see if you need to make some data improvements. Okay, so I will stop this and just type Control Z and let's continue. So now that we allowed our assistant to understand what the user say, we would like to enable our assistant to actually use that information and respond in a certain way. So first of all, the user choice entity is actually really important because depending on what choice the user will make, a meme or a joke, our assistant will have to run a specific action depending on that. So this detail entity, user choice, is a very important piece of information that will influence how the conversation goes later. So having the detail in assistant's memory is important. And you can store details in assistant's memory by using slots. So slots are another detail in Rasa open source that allows you to enable your assistant to handle context, to remember details throughout the conversation, use those details when running specific actions, and so on. So I would like to create a very simple slot that will store the value of the user choice entity and will enable our assistant to use that value later on when executing the action depending on what was the user's choice. So let's create a new section called slots inside of our domain file. And now we can provide the name for our slot. I will call it exactly the same way, user choice. You can call your slots any way you want. It just simply has to be representative of what kind of information that slot will be storing. And now we have to provide a few details about the slot. First of all, we have to provide the type. Unfortunately, this is not that part of this workshop, so I will not go into details here, but I will provide the type any for this slot, which means that what kind of slot this is, it will not influence the conversation in any way, depending on, it will only depend on whether or not the slot is filled in. And I will talk about this a little bit more later, but slots is a little bit bigger topic, so I would like to encourage you to check out the documentation after the workshop to learn more about different types of slots. Because in some cases, the actual value can be very specific and it can influence how the conversation goes and so on. In this case, let's keep it simple and just choose type any. And now we also have to provide the mapping for the slot. So very quickly about the mappings. With mappings, you can define from what kind of details this slot will be extracted. So for example, will that be extracted from entities or some other details, and what kind of entities could be used to extract the slot, and so on. So in this case, we will have the type for this mapping from entity, because we will use the value of the entity to fill in the slot, and we can also provide the actual entity for it. And in our case, that will be user choice. And last but not least, we can also even specify the specific intent that this will be extracted from, and this will be the intent in form. Just one thing to remember to make sure that we align things the right way. Okay, so we can save this. And the next thing that I would like to edit is responses. So we will want our assistant to, instead of just immediately saying goodbye, ask if the user would like to get a joke or a meme. So we will create a new utterance. And that new utterance will be, let's say, do something else. And now we can provide the text input, which will be, I can also tell you a joke or send you a funny meme. Which one do you prefer? Right. So with this, we will enable our assistant to choose, and then we will have an assistant running specific action depending on the user's choice, and then maybe after that it will say goodbye. Okay, I would like to double check my assistant, so I will retrain the model just to double check if I didn't make any mistakes. And while this is training and while we are checking, I will talk about what else do we have to do. So there are basically two main things that are left for us to do. One is to implement the custom action that will check what was the user's choice, and based on that, running the specific action. And we will also have to update the training stories to make sure that our assistant is able to use these additional user inputs, and that our assistant is able to simply use that information and respond in a certain way. Okay, so everything trained correctly, so I think we didn't make any big mistakes in the domain file. By mistakes, I mean a typo, and it happens to everyone. Okay, so now that we have this in place, I would like to go to the actions file. And here I will want to implement custom action. So if you go to actions directory, you will see actions.py file. This is where you have a starter for a custom action. And I will want to use that to basically implement some fun custom action for my assistant. So I will uncomment everything here. You can do that by highlighting all of the code here, and then using command / combination. Since this is just a simple text, I will delete this, or you can keep it, or actually I can comment this. So you can see more details about the implementation of custom actions. So what happens here? A custom action is basically any kind of custom Python code that you would like your assistant to run. In your custom actions, your assistant should be able to access slots, and depending on those slots, values, for example, run a specific action, and so on. So we will do that. It will be a very, very simple custom action just to get you a taste how this can be done in Rasa open source. So custom action consists of two main points. It's a class overall and consists of two methods. One is called name, and this simply provides you a name of your custom action, action hello world. We will have to list it in our domain file in a second, but before that we can implement the run method of our assistant, which will simply execute some custom code, whatever code we would like our assistant to run. So this is where we write all the code we would like our assistant to be able to handle. So that is just one very simple thing that I would like my assistant to do. First of all, I would like my assistant to check what is the value of a slot user choice, check if that's a meme or a joke, and depending on that, send the user a specific response. So let's do that. I will create a variable called choice, and that will be the user's choice. And now we can access the slots that are filled in at a specific state of the conversation using a method tracker get slot. Not tracker, it's a tracker. And in the parentheses, we can provide the name of the slot that we would like to get access to. And in our case, that will be user choice. And now choice will be filled in with the current value of the slot user choice. Now I would like my assistant to check what is the value. So if choice is meme, then I would like my assistant to send the message to the user saying just simply this is a meme. So we will not implement the actual implementation for that. You can, for example, use an interesting API here after the workshop and actually pull out the meme from somewhere. But we will simply send a message. And this can be done using the dispatcher method, utter message, which is simply sending message back to the user in a custom action. So I will copy this and I will do it here. So instead of saying hello world, our assistant will say this is a meme. If the user asked for a joke, we will send a bit different message, which will be, I'll just move it below, and this will be, this is a joke. And that's it. In some cases, your custom actions can also return some additional details, set slots as well. It's, again, something that you can learn more after this workshop. But for our specific case, this is enough to implement a very simple custom action. So I will save this file. And now we have to go back to our domain file and include this action hello world, inside of our domain file. Okay, so if I go to the domain file, we have to create a separate section here, which will be called actions. And this section will contain all of the custom actions that your assistant will be able to handle. And in our case, we will have action hello world. Okay. Let's keep it in line with everything else. So this is all that we need for our assistant to be able to run the custom action and respond. And the last thing that I would like to do is I would like to update our stories file so that we can actually run this custom action and see it working. So I will go to the stories file. Also, don't forget to save the changes and also actions file. So if we go back to the stories file, let's see, we will have to modify some stories where the conversation doesn't go as we want. So the first happy path is actually should not be affected by our change that we are implementing because everything goes well here and the user is happy. Now here, the sad path number 1, assistant tries to cheer the user up and the user actually in fact became happier after they saw the picture of a cute tiger cub. And this is the story that we would like to update because once the assistant tries to cheer the user up and asks if that helped, the user says no, that it didn't. So we would like to update this story. And then when the user says that they still don't feel happy, instead of saying goodbye, we would like our assistant to say, utter, do something else. Because if I quickly go back to the domain file, you see that this is the different utterance that we created, where assistant will say, I can also tell you a joke or send you a funny meme. Which one do you prefer? And now the next step for the user would be to choose like what kind of thing they would like to see. So they will see, they should provide the intent in form. And we have to make sure that our assistant knows that we will want to extract entities as well. So we'll provide entities. And in our case, let's say the entity will be user choice, and we can provide the example value, which will be meme, for example. So this is how we can train our assistant to understand that we will also be extracting some entities. And now, once the user provided their choice, our assistant should be able to run the custom action. We call that action action hello world, so we can call it that. Oh, that should be action. And I will finish the story here, but obviously you can extend it and allow your assistant to say, did that help you now? Or for the user to say hello, goodbye, and things like that. But I just want to see that this custom action is running, and basically this is our goal for this assistant to work. Okay, so that should be enough. And what we have to do now is we have to retrain our model and test it and see if everything worked as we hoped. So I will do Rasa train once again. And if we did make any typo somewhere, this is the point where we will figure all of these things out. And actually, one thing that I just remembered as I'm speaking. So since we will be using custom actions, Rasa runs custom actions on a different server than your actual assistant. The reason for that is because if you will want to make some changes to your custom actions code, you would need to restart your entire assistant. You can only restart the action server and so on, and those changes will be picked up. For that to work, we will need a different server for our custom actions, and this can be configured inside of the endpoints.yaml file. As you can see here, we have quite a few configurations, and what we will be using is a simple custom action endpoint. And to make sure that we can use this custom action that we just implemented, I will have to uncomment action endpoint and the URL that it will be using. So when this is enabled, our assistant will be using this webhook with a port 5055 for the custom action server, and our assistant then will be interacting with our custom action server. So I will save that. And now I actually would like to test it. So to test our assistant, we will have to start the custom action server, and we will have to start our Rasa assistant. So to do that, we can run Rasa run actions, which will start the custom action server, and we can do Rasa shell, which will load our assistant. And then we should be able to talk to our assistant in a command line. So let's test it. So we can see that our custom action hello world has been registered. It's available. Now we are loading our model, and we should be able to see if things work. Okay, let's test it. So I will say, hello. My assistant asks, hey, how are you? I will say, I am sad. So my assistant tried to cheer me up, and now it asked me if did that help me, and I will say no, because we are testing that story that we were updating. And our assistant says, instead of saying goodbye like previously, it now says, I can also tell you a joke or send you a funny meme. Which one do you prefer? So we can actually go to our domain file, and we can see that our assistant now responded with utter do something else, just like we wrote in that story. So this is perfect. And now let's test if our implementation of a slot and custom action actually works. So I will do a meme. Okay, perfect. So it's very subtle, and I hope that you can see what is happening here. So I as a user, I chose that I want to see a meme, and my assistant responded with, this is a meme. What happened in the background is our assistant executed the custom action that we implemented here inside of the actions.yaml file, and it checked that my choice was a meme, that the slot value was a meme, and our assistant responded with, this is a meme, a message. So yeah, so this is very simple and very quick introduction to how we can use Rasa. As you can see, we did improve a little bit how our assistant responds, and I would like to encourage you to play around with this bot more and implement more custom actions. Expand how your assistant handles the conversations. You can improve this conversation even further and make it even nicer, and build new things on top of this assistant. And if you do that, please share those assistants with us. I would really love to see what kind of things you come up with. But I really hope that all these simple steps that we went through will help you understand a little bit better what kind of components go into your assistant, and what kind of things you have to do to alter the behavior of your assistant and improve it. So this is it for the practical part. I will want to quickly recap and give you some additional tips on how you can improve your assistant as you go forward and make your assistant even more advanced. So I will go back to my slides, and I will finish my session by mentioning a few things that I think will be very important for you to think about as you keep using Rasa and hopefully building more advanced AI assistants. So as you saw right now, we did quite a bit of work and added some additional things to our assistant by simply writing some additional stories, creating new custom actions, and so on. This is great, and this is usually how the initial stages of building your AI assistant look like. Like, you are a developer, you are writing some training data, you are thinking about what kind of things you would like your assistant to handle, and so on. But there is a big flaw with this. The problem with this kind of approach is that you can't really rely on one developer or even just a group of developers to build your assistant all the time. And the reason for that is because if just a few human beings create the training data for your assistant, obviously that training data will be not only biased, but also very limited, and it will not represent the real world situation for sure. So at Rasa, what we encourage developers to do is to think about how you can involve real testers into your development cycles as soon as possible. So when you are at the stage where you built your assistant so that it is capable of handling at least the most basic conversations, just like we did with the Moodbot right now. Once you have that, you should be including real testers into your development cycle, allowing real testers, real people who had nothing to do with the development of your assistant, to talk to your assistant so that you can gather some information about how real people will talk to your assistant. And that will help you to learn so much about how you can improve your assistant, what kind of additional conversational turns you should enable your assistant to handle. You will be able to learn what kind of new skills you should add to your assistant. And all of this is actually a term that we call conversation-driven development that we encourage our developers at Rasa to practice. So conversation-driven development is basically a cycle where you at first build your assistant, and you include continuous integration and continuous development aspects to your assistant, meaning that you constantly test your assistant. If it passes the tests, you build the system that enables you to make sure that all the new changes that you add to your assistant, that they are improving your assistant, that you are not breaking them. But basically, you have a working version of your assistant. Then you share your assistant with real testers, and they talk to your assistant. You collect those conversations, and then you can review those conversations and improve your assistant based on what you learn. This whole cycle can be made easier with another tool which is free and is built on top of Rasa open source. It is called Rasa X. It's a really nice UI that allows you to basically follow the entire conversation-driven development cycle, which consists of 6 main steps. Sharing your assistant, reviewing those conversations, annotating new conversations, testing everything, and then tracking how those conversations influence your assistant's performance, and fixing anything that still needs to be improved about your assistant. It can be a specific skill, it can be specific conversation, and so on. All right. I will leave you with that, and I just wanted to share some really useful resources and places where you can go to learn more about Rasa open source, about our community, and hopefully even share assistants that you build with Rasa. We would love to see them, so please tag us on the forum. And in general, forum, our community forum, there is a link, is a place where you can find other like-minded people that are interested in conversational AI. Also, you will find the Rasa team there as well, and you will be able to ask any technical questions on the Rasa forums. If you would like to learn more about Rasa and find some educational resources that would go even deeper in all of the topics and things that we covered today, check out the Rasa Learning Center. Over there, we have a lot of videos, we have a lot of tutorials, we have even full-on courses that you can do on Rasa and learn all the inner workings of Rasa open source. And obviously, make sure to check out the Rasa documentation. So yeah, thank you so much for following my session today. I really hope that you learned something new and that all of this information was useful. And if you have any additional questions, feel free to drop them in the forums of Rasa. I will be there, and I will be definitely checking and keeping my eye on any questions that might come from you. I hope that you enjoy the rest of the conference, that you learn a lot of really interesting things, and that you build some really, really great conversational AI applications. So thank you so much once again, and have a great day.